page 445, assignment 8.6. Researcher claims that the variance of the number of yearly forest fires in the United States is greater than 140. So let's go ahead and write, well, let's finish reading and then we'll come back. That's probably going to give us our claim right there. For a 13-year period, the variance of the number of forest fires in the United States is 146. Test the claim at alpha equal 0.01. What factor would influence the variation of the number of forest fires that occurred in the United States? All right, first sentence. A researcher claims the variance of the number of forest fires in the U.S. is greater than 140. So we're going to write our null and our alternative hypothesis. So greater than 140, would that go in the null or the alternative? Right, because it's greater than. It's not greater than or equal to. So greater than 140. Now, make sure you use the right symbol. What's the symbol for population variance? That's population variance. It's the population standard deviation squared. So you got to make sure you get the right symbol here. You got to read carefully. So then the null would be that the population variance is less than or equal to 140. The claim was down here. The claim was that the variance was greater than 140. And it'd be 140 forest fires would be the label on that. Okay, now looking at a 13-year period. So n's going to equal 13. Because they looked at 13 years, sample size. And they're saying the variance for those 13 years was 146. In other words, your s squared is 146. Remember, s squared is the symbol for sample variance. Your alpha is 0.01. Tells you that in the problem. So this was step A. Step B, we're going to find our critical values. Anytime you're dealing with anytime you're making some type of a claim about a standard deviation or a variance, use your chi-squared chart to find your critical values. Now, is this going to be left-tailed or right-tailed? Or two-tailed? Right. If it's a greater than it points to the right, it's going to be right-tailed. Okay? So we're only going to have a chi-squared right on this one. If that would have been a less than in the bottom, then we'd only have a chi-squared left. So we're going to have a chi-squared right. This chi-squared right will be our critical value. So you go to, let's see, so this area is 0.01. You don't need to divide by 2 because there's only one tail. So go to your chi-squared chart. Degrees of freedom would be 13 minus 1, so degrees of freedom would be 12. So go down until you find 12 in the degrees of freedom. Then go over to the right side of your chi-squared chart until you find 0.01. What number does that give you? 26.27 what?
217. 217.
217. Okay, others agree with that? Anybody? Okay, so that's your critical value, your chi-squared right of 26.217. Remember with the chi-squared chart, this is 0 here. The graph starts at 0 and goes to 26. Our critical value is at 26.261. So we're going to do a test value now. If it falls between 0 and 26.261 or 216, we'll say do not reject the null. If it's greater than 26.216, then we'll say reject the null. All right, so our critical value, chi squared equals n minus 1 times s squared over sigma squared. So n minus 1 would be 13 minus 1. Now, s squared, what should you put in for s squared?
146.
146. I'm not going to square it. I'm just going to put 146. Why aren't I squaring that? It's already been squared, yeah. The variance was given. If they give you the variance, that means they've already squared it for you. If they gave you the, like over this other example, here, they didn't give us the variance. We got the standard deviation off the calculator. So we had to square it. So if the standard deviation is given, you're going to have to square it. But if the variance is given, then you don't need to square it. It's already been squared. Same thing with the variance on the bottom. The variance, the hypothesized variance is 140. So you're not going to square it, you're just going to put a 140 here. chi-squared is gonna be 12 times 146, and then divide by 140. What's that come out to? 12 point what? 12.5, and that would fall in here somewhere, right? It's between 0 and 26, so what would I say for part D? Do not reject the null. So we're not rejecting the null. So if we're not rejecting it, that means we think the null's probably true, which means we think the alternative's probably false. So would there be enough to support the claim or not support the claim?
There's enough.
There's not enough evidence to support the claim. Okay? If we're not rejecting the null, we think the null is probably true. We're not proving it, but that's what we think. So we're going to say there's not enough evidence to support the claim here. Not enough evidence to support the claim that the variance is more than 140 fires. Yep, 140 fires, forest fires. Any questions about that? That's good.